Good evening. I'm starting the discussion. So I will start with the essay paper. So first we'll start with the essay paper. Question number 1, part A. An object is released from a point P. That one. Read it. Question number 1, part A. Okay, an object A is released from a point P having 5-meter height from the ground. An object A, let's say this is the object A, it is released from a 5-meter height. It is released from a 5-meter height from the ground, released. So what is the initial velocity? It's 0, released the ground. After 0.5 seconds, another object B is released from the same point. Okay, the velocity that A bounces back after hitting the ground is 75% of the velocity that it hits the ground. Okay, yeah. So first question: find the time for A to hit the ground. Okay, I'm going to find the time for A to hit the ground. A is released from a 5-meter height. It will come down like this, and it will hit the ground with the velocity v. What is v? Applying v square is equal to u square plus 2as. What is v? V square. Initially it's 0, released. Then 2. When an object is released from a higher point and it is coming downward, acceleration of gravity is plus 10. It has to come 5 meters. Okay. So v square is equal to 100. So the velocity that it hits the ground will be 10 meters per second. Velocity that it hits the ground 10 meters per second. Okay. And then velocity that A bounce back. Okay. After hitting the ground with a velocity of 10 meters per second, it will bounce back. Yeah, it's 10 meters per second here. I will draw the next step here. It's moving up in the same line. So I'll draw it in the same line as it is. Okay, when it hits the ground, it will move back in the same line, but some of its energy will be absorbed to the ground. Some of its kinetic energy will be absorbed to the ground. So the velocity that it bounces has reduced from a 25%. So what is the value? Now it hits the ground from a 10 meters per second velocity. It will move up with the velocity of 7.5 meters per second. It will move up with the velocity of 7.5 meters per second. Okay, 25% is wasted. Then velocity that A bounces back. It's okay. So the next question: distance traveled by A when it's collide with B. That's the question you have to face. Now let's see. A is released from a point where it's have a 5-meter height from the ground. A will come down and hit the ground with a velocity of 10 meters per second, and then it will move up. With a velocity of 7.5 meters per second. Now B is released after 0.5 second from the initial release. After the release of A, it took 0.5 seconds to release B. So B is 0.5 seconds late. Okay. Then to understand this, shall we find the time to go through this third question to solve this? I thought of finding the time that capital A hits the ground. I need to know the time that capital A hits the ground. Applying V equals U plus AT for capital A. Actually, when it hits the ground after 5 meters, its velocity is 10. Initially, it was released as 0 then. Acceleration of gravity is 10 t. That gets the first clue. Okay, it took 1 second for A to hit the ground. Okay. Now, when we say it took 1 second for A to hit the ground, from this 1 second time period, actually B's life was only about the 0.5 seconds remaining. Why? B was released 0.5 seconds later than A. So What happens when capital A hits the ground? It took 1 second for A to hit the ground. Within that 1 second time, 1 minus 0.5, only 0.5 second is the time that B was in its motion, as it was released later. Okay, so about B, it was released from the same height with a 5-meter value. About B, it was released from the same height with a 5-meter value from an initial 0 velocity. Then B will come down for 0.5 seconds. That means 1 minus 0.5, answer is 0.5. 1 minus 0.5, answer is 0.5. B will come down for 0.5 seconds at the moment where A hits the ground. Can you understand that? Because to hit the ground, A took 1 second time. We found that. But from that 1 second, 1 minus 0.5, as B was 0.5 seconds released later, then B had the chance only to be in the motion for the remaining 0.5 seconds. Okay, so shall we find the position of B after 0.5 seconds of its motion? 0.5 seconds of its motion means capital A has spent 1 second in its motion and capital A has hit the ground, and at that instant A is moving other side with a 7.5 meters per velocity. So this is the situation of A after 1 second of its after 1 second of its motion. That means 0.5 seconds after B started. Okay, so I'm going to find the details here. Applying V equals U plus AT for B, we will have a velocity of initial velocity 0, acceleration of gravity 10 into 0.5. We will have a velocity of 5 meters per second at this moment, and applying V square is equal to U square plus 2As, 5 square 0 plus 2 10 S, 25 is 20 S, so S is 1.25. So capital A took 1 second to reach ground. From that 1 second, within that 1 second, B's flying time was only 0.5, as it was released 0.5 seconds earlier, 0.5 seconds later to A. So at the moment A hits the ground, that means in the same instant it bounces with a velocity of 7.5 meters per second. At that moment, B has finished 0.5 seconds from its journey, and it has reached to a velocity of 5 meters per second, passing 1.25 meters towards ground. So this is the case now. B is here and A is trying to move up now. So thought of drawing that particular situation again. A is trying to move up with a 7.5 meters per second velocity. At this moment, B is here. It has passed 1.25 meters from the top. That means the complete length gap is 5 meters. So it means, it hints that there's another 3.75 meter gap between them. 3.75 meter gap between them. Okay, so this is the situation after 1 second from capital A's release. This is the situation after 1 second from capital A's release. This is the situation after 1 second from capital A's release. Within a 1 second time, capital A come to the ground, passing 5 meters, and at the same instant, it bounces back without any time lag. It bounces back with a velocity of 7.5 meters per second after 1 second from capital A's release. When the time is 1 second from capital A's release, it means for B, Now it has passed 0.5 seconds as it was released 0.5 seconds later. The 1 minus 0.5 again 0.5. So B has passed B has spent 0.5 seconds in its journey, coming 1.25 meters. That means remaining 3.75 with ground and gaining a velocity of 5 meters per second. Okay, so this is the situation now. Now let's see distance traveled by A when it collide with B. Okay, from here I'm starting again. From here, let's say A have to move a distance x. A have to move a distance x to collide with B. Then B will come down and B have to move. Shall I use a different color pen? Okay, so that means A have to move a distance x upward. Let's say B has to move a distance y downward to collide with A. The distance that B travels is y and the distance that A travels is x. These x and y are the distances traveled by these particles after 1 second from the initiative from capital, after 1 second that capital A initiates. Okay, so after 1 second that capital A has started, A is on the ground trying to move up. After 1 second that capital A has started, B has only spent 0.5 seconds in its journey, so it has come to a position like this. From that, now I'm starting to calculate time after that 1 second. Now I'm starting to calculate time after that 1 second. So after that 1 second, to these particles to be collided, this capital A has to move a distance x upward and capital B has to move a distance y downward. I'm writing capital T here. I'm introducing the symbol capital T. T is the time that particles spent after 1 second from capital A's initial release. Okay, T is the time that I'm going to use here. This T, it starts after 1 second from A's initial start. Okay, applying S equals ut plus half at square. Applying S equals ut plus half at square for capital A. A has, after bouncing, A has gone up for a distance x. A's initial velocity is 7.5. Let's say this is the place that I'm going to start calculating time. So from here, it will take capital T to reach this point. T plus half minus 10 T square. Okay. When capital A spends this time period capital T, it started 1 second after capital A's beginning. That means it started when capital A started to move up with a velocity of 7.5. At that point, B, when A is starting to move upward, B has passed 0.5 second in its journey and it has reached to a position like this. From there, I'm starting to calculate the time T. So B has come another distance y downward to get collided with A. There, the spent time of B is again capital T. Okay, applying S equals ut plus half at square for B downward. For downward direction, here B has moved another distance y. B's initial velocity at this point was 5. I calculated it earlier. 5 capital T plus half minus 10 t square. Okay. Now these are the first and second equations I get. Now this is my next plan. This is my next plan. Now I'm going to add them. Now I'm going to add them. Okay. Adding 1 and 2. X plus, it will be x plus y in the left side. In the right side, 7.5t plus half minus 10t square. What else? Here 5t from y. 5t plus half 10t square. Okay. X plus y. What is x plus y? X plus y is the remaining distance that B has to reach ground after 0.5 seconds of its time. So x plus y, what is the addition? It's 3.75. X plus y, it's 3.75. The remaining distance that B has to travel downward after the 0.5 seconds time of its motion. Okay, 3.75. Here, half minus 10t square will cancel out with half plus 10t square. So 7.5t plus 5t, it's 12.5t. So what is t? 3.75 over 12.5. So I can remember the answer. It's 0.3 seconds. T is equal to 0.3 seconds. Okay, shall I check it again? Yeah, it's 0.3. It's 0.3 seconds. Okay, so now this is the case. Initially, A was released from a 5-meter height. It came this 5-meter length downwards and hit the ground with a velocity of 10 and bounces back with a velocity of 7.5 meters per second. To do that, capital A took a 1 second time. Within that 1 second, as B was released 0.5 seconds later to A, B had the chance only to travel for 0.5 seconds time. 1 minus 0.5, again the answer is 0.5. So within that 0.5 seconds, B came downward a distance of 1.25 meters, gaining a velocity of 5 meters per second. Now let's say I'm starting to calculate the time again from a 1 second, after a 1 second time period from A's initial release. Now again, after 1 second from A's initial release, now A is starting to move up with a velocity of 7.5. At that moment, as B has spent only 0.5, B is in this position with a 5 meters per second velocity downward, a distance 1.25 down. That means its remaining distance, the distance gap now is 3.75. Okay, now I'm applying equations again for capital A upward. S equals ut plus half at square upward. Let's say at the moment that they collide, x has moved up, A has moved up for distance x. Initial velocity 7.5, time from there onwards capital T. X is equal to 7.5t plus half minus t minus 10t square. Within that time, B has reached another y distance downward. Applying S equals ut plus at square for B downward, it has moved a distance y again, y. U, initial velocity is 5 at this moment, 5t ut plus half minus half plus 10, half plus 10 t square. Okay, now I'm adding x plus y from the left side, from the right side, 7.5t minus half 10t square, 5t plus half 10t square. This half 10t square will cancel out. In one case it is minus, in the other case it's plus. You will get 12.5t there, and in the left side you will get x plus y. What is x plus y? It is the distance gap between the ground and point B after its 0.5 after its 0.5 second initial journey. So x plus y is equal to 3.75. I got the answer. Okay, here x plus y 3.75 and I calculated t 0.3 seconds. Okay, now I'll go to answer the question what that they ask. They ask distance traveled by A when collide with B. What is the distance traveled by A when collide with B? To do that, initially I had to find x. Now I'm going to find x. X is equal to 7.5t plus half minus 10 t square. 7.5 into 0.3 minus 5.3 square. 7.5 into 0.3. 7.5 into 0.3. Here I am substituting the capital T value to this place. 7.5 into 0.3 minus 5, half into minus 10, minus 5.3 square, and I will give you the answer. Here 2.25 minus 0.05, and you will get the answer 1.8 meters. You will get the answer 1.8 meters. So x is 1.8. So again, after it bounces from the ground, it has to move for 1.8 meter distance upward to be collided with B. Initially, A came 5 meter downward. So what is the distance traveled by A? So what is the distance traveled by A? What is the distance traveled by A? Initially, it came for a 5 meter distance downward to hit the ground. From there, it moved another distance x upward to meet B. So 5 plus x. 5 plus 1.8. 6.8 meter is the distance traveled by A when it collide with the B. Okay. Velocity of A when it collide with B. Velocity of A when it collide with B. Now you can solve that. Applying V equals V square is equal to U square plus 2as for A from ground. At the ground, when it was bounced, it had the velocity of 7.5 square to upwards minus 10 to A S. What is x? It's x. What is x? 1.8. 1.8. So I'll give you the answer. I'll provide the answer. You will get 4.5 meters per second for this answer. You will get 4.5 meters per second for this answer. Okay. Okay, I'll give you the time to finish the question. Meantime, I'll explain it again. Now I have left the board for you to write down and note down these important areas. Meantime, I'm going to explain. So this is the situation. I have left the board for you to write down. Meantime, I'm going to explain. Now, initially, A was in a position where it was 5 meters up with respect to the ground. A was released, and to reach these 5 meters to hit the ground, okay, then A hit the ground with a velocity of 10 and it bounced back with a velocity of 7.5 meters per second. That was the first two questions that you were asked. Then what happened? After 0.5 seconds from A's initial release, there was another particle which is B. It was released from the same initial point. So now we calculate the time for A to reach the ground. A took a 1 second time to reach the ground. But as B was released 0.5 seconds after A, when A hits the ground and at the same instant when A bounces back with a velocity of 7.5 meters per second, at that moment B spent only 0.5 seconds in its motion. So within that 0.5 seconds, B gained a velocity of 5 meters per second downward with a travel distance of 1.25 meters. As the initial gap was 5 meters, now B has reached for 1.25 meters downward. That means at that moment, B had a distance of 3.75 meters from the ground. Now B has a distance of 3.75 meters from the ground, and B has a downward velocity of 5 meters per second. Now B will continue its journey while A starts to move up with a velocity of 7.5 meters per second. Okay, now what will happen? Let's say to be collided with each other, A has to move a distance x upward while B has to continue for another y meters downward. Applied s equals ut plus half at square for this distance x for A. X is equal to 7.5 capital T plus half minus 10 t square. Okay, the capital D is the time period starting from the first second of capital A. It took 1 second to reach ground and bounce back. Now I'm starting to calculate the time from that certain instant. From there, within a time period of capital T, A will reach a distance x upward. Meantime, in that same time period, B will move for another distance y downward and it will get collided with A. Okay, applied s equals ut plus half a t square for B, then s is equal to y, initial velocity 5, so 5t plus half minus plus 10 t square. Then added the both equations where x plus y is equal to the gap between B and the ground when A hits the ground, 3.75, 12.5 t. Then I calculated t. Substitute t for the equation here and got the answer for x. X is the distance that A traveled up to be collided with B. Initially, A came for 5 meters downward, so the distance is the length of the travel, 5 plus 1.8, 6.8. Meantime, okay, I have to calculate the velocity that A hits B. So calculate the velocity for A to move another capital T time period upwards and got the answer. Okay, V square is equal to U square plus 2S, U square 7.5 square, 2 minus 10, another coming for a distance x upward, 1.8. Got the answer. Okay, now I think you got enough time to handle the situation. Now I'm going to part B. Part B, it's a question related to projectile motion. Okay, an object is projected from point A at an angle of 30 with horizontal. Let's draw. That's a position like this. Let's say it's a cliff of 3 meter high. An object is projected at an angle of 30 to horizontal with a velocity of 4 meters per second. So you will see a projectile motion like this. In this projectile motion, you know, when we project something with an angle to the horizontal, we can resolve this velocity vector to its horizontal and vertical components. 4 cos 30 is the horizontal component of the initial velocity, and 4 sin 30. 4 sin 30 is the initial vertical component of the velocity. Now we know the actual motion is a projectile motion like this in a parabolic path. But in the vectors lesson, you have learned that these horizontal and vertical vectors, they are perpendicular to each other. So you can deal with them independently. Why? Independent the vectors with the angle of 90 will not affect the other. So the horizontal velocity component will not affect the vertical motion. Vertical velocity component will not affect the horizontal motion. So you can deal with them separately. Okay. Now, what is the first question? What is the velocity of the object at point B? Okay, this is point A. The highest point is marked as B. The point where it passes the same horizontal line, it's named as D, and the point where it hits the ground is named as C. Okay, then what is the velocity of the object at point B? Now you know its initial velocity is divided into two parts, 4 cos 30 and 4 sin 30. This is the maximum height. At the maximum height, it doesn't have a vertical velocity. If it has a velocity, it will travel more up. It will not travel more than this point. It will not reach to a higher level. This is the maximum point because it doesn't have a vertical velocity left. Why? Acceleration of gravity is downward. The gravitational force is downward. It's attracting the object always towards the ground. So the initial velocity component in the vertical direction will reduce little by little. So at the highest point, there is no any vertical velocity component. Velocity is 0 when you consider the vertical direction. The other point, the acceleration of gravity is vertical, so it will not affect the horizontal. So what will happen? Its initial horizontal velocity component will not change. Its initial horizontal velocity component will not change. Initial component is 4 cos 30, 4 root 3 over 2, that means 2 root 3. It won't change. Why? Acceleration of gravity is vertical. It can't affect the horizontal. So the initial horizontal velocity component will remain same throughout the motion. At the highest point, there is no any vertical velocity component. We explained it. But always, there's this horizontal component remaining. So even at the highest point, horizontal component is there. What is the horizontal component? 2 root 3 meters per second. Now at the highest point is, as there is no any vertical component, the complete velocity will be the horizontal component. As there is no any vertical component to take the vector addition with this horizontal component, only remaining velocity is the horizontal component at the highest point. So it's the velocity. So what's the first question they ask? What is the velocity of the object at point B? At point B, total velocity is 2.23 meters per second. 2.23 meters per second. Okay, that means what's the answer? I'll give the simplified answer. 3.464. 3.464 meters per second. At point B, the total velocity is 3.464 meters per second. It's the horizontal velocity component, as there is no any vertical component at the highest point. Okay, the second question. Calculate the flying time of the object. Calculate the flying time of the object. I'm applying S equals ut plus half at square for the object upward. The flying time is this. It hits the ground at the point C. Initially, time is 0 when it was projected, and it will come in this parabolic path and it will hit the ground at C. So the time taken to reach from this point A in the parabolic path to point C is the flying time, capital T. We know the actual path is a parabola, but as the perpendicular vectors does not affect each other, we can find things in the vertical and horizontal planes separately. I'm going to use the vertical plane to find the flying time. If I leave this horizontal plane for a second and pay my attention to the vertical plane, vertically what's happening here? Initially it was at a 3-meter height from the ground. Vertically it moved up and passes the level of this 3-meter value and it came down. Forget the horizontal component or the horizontal motion. Vertically what has happened? It has come for 3-meter distance in the for 3-meter displacement in the other side. Displacement is -3. Displacement is the gap between the initial and final points. Displacement is not the distance traveled, it's the gap between the initial and final point, the shortest distance. So the displacement is the gap between the initial and final points. Here, initially object, I'm leaving the horizontal, I'm dealing with the vertical. It from a 3-meter height started and moved up until the highest point, came back, passed this 3-meter level and reached the ground. To reach the ground, it has a certain distance that it has traveled. But displacement wise, as the displacement is the gap, it's a 3-meter gap downward from the initial point. So it's a value of -3. And you are applying the equation upward. So initial velocity, 4 sine 30 upward, 4 sine 30. 4 sine 30 flying time t plus half minus 10 t square. Minus 3 is equal to 4 sine 30, sine 30 half t minus 5 t square. Minus 3 is equal to 2t minus 5t square. 5t square minus 2t minus 3 is equal to 0. I'm going to solve this quadratic equation. 5 times 3, it's 15. And here 5 and 3, I need to have -2 plus 5 and -3. I'm sorry, -5 and plus 3. Okay, 5t square minus 5t plus 3t minus 3 is equal to 0. Taking 5t out, t minus 1 plus 3, t minus 1 is 0. T minus 1, 5t plus 3 is equal to 0. T minus 1, if t minus 1 is 0, t is equal to 1 second time. If 5t plus 3 is equal to 0, t is equal to -3/5. T is not a minus value in Newton mechanics. So correct answer is flying time is equal to a 1 second value. Flying time is equal to a 1 second value. That's the correct answer. Okay. Now flying time is equal to a 1 second value. The third question, what is the velocity of the object when passing point D? What is the velocity when the object passes D? D means the same level that it started. Okay. Now you can apply equations and check, but from the motion under gravity lesson, you know that when an object passes the same level to the opposite direction, when an object passes the same level that it started to the opposite direction, after a certain time, it has the same velocity value downward. So the downward velocity will be 4 sine 30 at this moment. How you took that? Applied v equals u plus at. Initial velocity is 4 sine. Wait, I will show you easier method. Now, I can't waste more time for the things that I have done so many times. So I will tell it to you. Okay. In a projectile, the vertical and horizontal components are treated separately. The vertical component is same as the motion under gravity. So in a motion under gravity question, when an object is projected with a certain velocity upward, it hits the ground or this same level with the same velocity value to the opposite direction. So here its velocity upward at this level is 4 sine 30. Okay. So it will hit the ground. If it's a motion under gravity projected from the ground, it will hit the ground again, reaching the same level with the same velocity value to the opposite direction. That's what happening here. So upward velocity is 4 sine 30. At the same level here, you have the downward velocity with the same value, 4 sine 30. And you know the horizontal velocity does not change. So it's 2 root 3 always, 4 cos 30. It's 2 root 3 always. So here, at the point, it passes the same level. The point D is having a velocity equal to the initial velocity value upward in the downward direction, and 2 root 3 horizontal velocity won't change. So what is its final velocity? VR. You know, as these two components are perpendicular to each other, we are at D, resultant velocity at D. What is the resultant velocity at D? We are resultant velocity at D, 4 sine 30 square plus 2 root 3 square into, you have to take the complete square root. Why? When two vectors perpendicular to each other are P and Q, what is the resultant? P square plus Q square, and you have to take the square root. Likewise, it has a downward velocity of 4 sine 30 and horizontal velocity hasn't changed, it's 2 root 3, they are perpendicular. So the resultant velocity at the point D is equal to 4 sine 30 square, 2 root 3 square into the square root value. And you will get the answer. Four meters per second. Get a nice answer. When you simplify this thing, you will get the answer. You will get the answer, and it's a nice one. 4 meters per second. Then what is the next question they ask? What is the maximum height that the object climb with respect to ground level? So as the next question, they ask the maximum height that the object climbs with respect to the ground level. From the ground level to this level, it has a 3 meter gap. Leave that gap. I am applying v square plus u square plus 2as from this level. I am applying v square is equal to u square plus 2as from the level that it started. At the highest point, upward velocity is 0. At the initial level, upward velocity is 4 sine 30. To minus 10 this h max. With respect to the level that it started, initial velocity is 4 sine 30 square, 2 minus 10 h max, 2as. At the highest point, it doesn't have upward velocity. So 20 h max Four sine 30 is 2, 2 square is 4. 4 sine 30 is 2, 2 square is 4. So h max is 4 over 20. 4 over 20 means 0.2. 4 over 20. 0.2. So this is 0.2 meters, and you have another 3 here from ground level. So the answer for the fourth part is equal to this 3 meters plus the h max value from here, 0.2. 3.2 meters. 3.2 meters. Okay. Question number 5. What is the velocity of the object when it hits the ground? What is its direction? What is the velocity of the object when it hits the ground? What is the direction? What is the velocity of the object when it hits the ground? Okay, when it hits the ground, that means at point C. Question number 5. Resultant velocity at point C. Resultant velocity at point C. Applying V equals U plus AT upward initial velocity is 4 sine 30. As I'm using the equation upward, it should be minus 10 here, and I'm applying the flying time. When the t equals 0 here, when we start to calculate time from here, it will take the flying time for the object to reach here. We have already got the answer for capital T, the flying time. Okay, applying V equals U plus AT for the flying time. 4 sine 30 is the initial velocity 2 minus 10. And what was the flying time? Flying time was equal to flying time was equal to 1 second value. So 2 minus 10 minus 2 meters per second. What is the minus 2? Yeah, after the flying time, object is moving vertically, it's moving downward. So minus 2 means, sorry, minus 8. Minus 8 means downward velocity is 8 meters per second. It took 1 second for the object to reach this point, a 3 meter displacement downward from its initial point. And to reach that point, we applied V equals U plus AT from the beginning. Initial velocity upward, it's 4 sine 30 plus upward velocity, when as we are applying the equation upward, acceleration is minus 10 t. T is 1. So what is the answer? Velocity after 1 second for this object is vertical velocity for this object after 1 second time is minus 10. Minus means it is in the other direction. It's moving in the other direction now, opposite direction. So downward. It's true with a velocity of 8 meters per second. Its horizontal velocity won't change. Its horizontal velocity won't change. So it's always 2 root 3. So what will be the final velocity here? VR. 8 square plus 2 root 3 square into square root. When the vectors are perpendicular, p square plus q square into square root is the answer for the resultant vector. So the resultant velocity here will be 8 square plus 2 root 3 square, and you have to take the square root, and you will get the answer as 8.72 meters per second. 8.72 meters per second. Okay. Then what's next? Let's find the direction also. You know, when the two vectors are p and q, let's say this is p, this is q, and this is the resultant vector. Normally, the resultant vector creates an angle alpha with the vector p, where tan alpha is equal to q over p. We have learned this theory really well. Now I'm just writing it here. Not going to prove this here. When two vectors are p and q, and when they are perpendicular, and the resultant vector, let's say VR, if it's creating an angle alpha with the vector p, tan alpha is equal to q over p. So you can use that method here. Then what will happen? Here you have the angle alpha, then tan alpha. Here you have the angle alpha. I am taking the angle alpha from this point, from this angle. If this is the angle alpha, this is the vector p, and this is the vector q. This is vector p, and this is vector q. So what will be tan alpha? Tan alpha is equal to 2 root 3 q over p. 2 root 3 over 8. Okay, you can continue that, and I will give the answer for this alpha. It's equal to I can't find the value. Okay, now you know the method. Okay, I'm continuing. This answer, and I have given the answer for the I have given the full marks for this point. Okay, then what is the horizontal range of the object when it hits the ground? So this is the horizontal range. So this is the horizontal range when it hits the ground. Okay, applying S equals ut plus half it. Sorry, applying S equals ut in the horizontal direction for the sixth question. For the sixth question, applying S equals ut in the horizontal direction, as the gravitational acceleration is in the vertical direction, it does not affect the horizontal. So you can apply S equals ut, where u is the constant velocity to the certain direction. It's the horizontal velocity component, it won't change, 2 root 3 multiplied by the flying time is the horizontal range that this projectile moves. It's r. 2 root 3 1.7 into capital T is 1, flying time is 1. Okay, then you will get the answer 3.464 for the question number 6. Then question number 7, plot the vertical displacement and the horizontal displacement. Okay, question number 7. Okay, horizontal displacement. Horizontal. What is the horizontal displacement? Actually, in a projectile, horizontal velocity does not change. So, in a displacement time curve, the velocity is given by the gradient. So, the gradient should be a constant here. So, it's a displacement time curve like this when you are considering the horizontal displacement. Okay, when you plot the horizontal displacement with time, the gradient will be the horizontal velocity. It's a constant. So it should be a graph with a constant gradient. So this is the horizontal displacement curve. Okay. And what is the displacement time curve for the vertical side? In a displacement time curve, the gradient shows the velocity. The gradient shows the velocity. So here, what happens to the velocity? Initially, velocity decreases until it reaches the highest point. Then, after the highest point, object starts to move downward. So the downward velocity increases. So the gradient will change the sign as the velocity changes the sign as it changes the direction, and value wise it will increase. This one. This is up to point D. After point D, what will happen? It will move to the opposite side from the initial point. So the displacements will be minus, and in that direction it will increase the velocity until it moves down. So the minus gradient has to be increased more and more. So it will be a curve like this. What's happening here? From the beginning until it reaches the highest point, it decreases the velocity, and velocity will become 0 at the highest point. So in a displacement time curve, in the vertical displacement time curve, the gradient will indicate the vertical velocity. The velocity is decreasing, so the gradient is decreasing. Velocity is positive in the upward direction, So the gradient should be a positive and it should be a decreasing one. Positive decreasing gradient from beginning until the H max. The displacement time curve looks like this. It indicates a positive decreasing gradient, the positive decreasing velocity. After the highest point, the object changes the direction and try to come down. There the velocity is minus, so the gradient is minus. In the downward direction, it increases the velocity until it hits the ground. So it's a minus increasing gradient. This is the minus increasing gradient. With that minus increasing gradient, it reaches a point which is a 3 meter value to the other side from the initial level. From the initial level, the displacements upward are positive, displacement downward are negative. So it should reach a minus 3 displacement value at the flying time after 1 second time. Okay, so that is the answer for the essay question. Now I am going to discuss the structure question that is related with this inclinometer. Now I am going to discuss the structure question that is related with this inclinometer. Okay. And the answers for the vernier caliper structure, I'll give it as a PDF. So now I'll be discussing the structure question related with our inclinometer case. Then we'll stop the class. So let's start that. Read the structure. First question. Okay. Object shown is called a clinometer and also known as an inclinometer that used to measure the vertical angles of slope or elevation. It is mounted to a supported that of height h naught. Okay. Now here's a hollow tube like this with a facility to measure the angle. When this hollow tube is in a position like this, you can observe from this point, keep your eye, and you will see the objects here. Meantime, as the weight is a vertical force, the weight hung from this point will stay vertically with its mass. So this is the vertical and this is how you observe the certain point. So here you have a scale in the degree value, so you can measure that angle, measure this angle. That's what happening here. So you can measure the angle with the vertical. Here there's a hollow tube like this. From this tube you can keep the eye here and observe the thing in this position. When you're observing it, it has this inclination like this as shown. Meantime, as a weight is a perpendicular force, the mass M hung here, it has this weight downward vertically, so it will stay like this with the string that it has hung from here. Okay, so here you have this facility to measure the angle and you can read the angle here. So this is the vertical, this is the line that you are observing. So you can read this angle from this point. Okay, so what is the question? Input විනාඩියකින් මම කතා කරන්න. හරි පල්ලෙහාට ගිහලා මමත් එක්ක වැඩ කරන්න. මම කතා කරන්න මේ ටීවර් කරලා. හරි. Okay. So use the above diagram to draw the angle that you are going to measure from this instrument. So I have asked you to use the initial diagram that I have shown to draw the angle that you can measure from this inclinometer. So this is the angle theta. Okay. Then part B. A student plans to measure the height of a dagger using this instrument. Okay. Now a student plans to measure the height of a dagger using this instrument. So this is the dagger, and this inclinometer is what they say. What's the distance? It's mounted to a support that of height 1.45 meters. This inclinometer is mounted to a support with a 1.5 meter height. Okay, so at this place you are keeping your inclinometer and taking the angle here, and don't forget that it's from a height h naught that you're going to start your measurements. So this is the 1.5 meter gap with the ground at the starting point of this hollow tube. Okay, and here you have this h naught. Meantime, you are measuring this angle. Shall I draw it in a larger scale? Okay. You can measure this angle. Okay. Initially, what's going on here? Through the inclinometer, you focus the top. Through the inclinometer, you can focus this top of the dagger, this point, and take the angle here. And to this point, and to this point, from the center of the dagger, you have a distance x. Then what's the next thing? You take the instrument little backward, and again you place it somewhere here, and again you are observing the highest point of the dagger while keeping the instrument in a position like this. Then what will happen? Through the facility, you will measure this angle. Okay, so here angle is theta here, and the angle here is beta. Angle here is beta. To do that, you took this inclinometer backward from a length L. Now, at the first part of question B, derive an expression for x using h and theta. Now here, from this level up to the top, the height is marked as h. This perpendicular height is marked as h. this side is H. So through the inclinometer, when you observe it like this, when you observe a point here through the inclinometer, as weight is a perpendicular vertical force, mg is acting like this, and this string stays vertically. So this is the vertical. You're observing something like this through the tube. So this is the path, the line that you observe. So through this, you can read the angle here. So this theta. So here, when you are pointing the inclinometer to this top from a distance x from the center, the angle you get is theta. If this angle is theta, look at the board carefully. If this angle is theta, what happens? This vertical line and the line drawn through the center, the vertical line drawn through the center is also here. They are parallel to each other. So if this is theta, this is theta. This is the vertical line. Weight acting in a vertical line. This is the vertical line. So if this is theta, this is also theta. So what is tan theta? Tan theta, adjacent leg. Theta is here, but it's same as here. This is also theta. So tan theta, adjacent leg. X. Opposite leg. I'm sorry. Calculating tan theta from this side, tan theta, opposite leg. X divided by adjacent leg, H. So X is equal to H tan theta. Problem number 2. When you take the inclinometer from a distance L backward, now you are observing the same point, and here the angle is beta. If the angle here is beta, as this line, vertical line, is parallel with this line, if this is beta, this is also beta. This complete angle, it's also beta. Then what's happened? What is tan beta? Opposite leg, x plus L. X plus L divided by adjacent leg, again H. So x plus L is equal to H tan beta. Derive the equation for x plus L using H and beta. The next thing, use the above equation and show that you have to show something here. In the final statement, there's no any x value. So third one, x plus L is equal to H tan beta and x is equal to H tan theta. Subtracted x plus L minus x, H tan beta minus H tan theta. X will cancel out. L is equal to H comes out. Tan beta minus tan theta. So what will happen? H is equal to L over tan beta minus tan theta. You got the answer. Okay. So in the fourth part, they ask, what is the other measurement that need to calculate H? To calculate H, already they have asked you to find theta and beta. The other measurement is L, the distance that the inclinometer was positioned back with respect to the initial point, L. What is the other measurement that you need? L, the distance that you pull the inclinometer backward from its initial point, L. So you can use this technique to measure a height. Now this is the height you need to measure. It's a good technique. So this is the height you need to measure. You know that. Take the inclinometer, place it from a certain distance, place it from a certain horizontal distance to this height, and observe the highest point. Take the angle here. Push it more backward to a position like this. Again, observe the same highest point from a position like this. Measure this angle beta and calculate the distance that you have to move this inclinometer backward, L. and you have to substitute in this equation and you will get the h height. So it's a good technique. Two angles that you have to measure through the instrument and the distance that you push the inclinometer backward, L, and you will get the height h here. Pure trigonometry. Okay, if the angle theta is, this is also a vertical line, this is also a vertical line, so they are parallel to each other. If this is theta, this is also theta. Tan theta is equal to x over h. If this is also a vertical line, the weight x, and this is also a vertical line, so they are parallel. So if this is beta, this is also beta. This complete angle tan beta x plus L over h. Use the equations to eliminate x and got the answer for h from beta, theta and L. L is a measurable distance. It's in the ground. Okay. Then calculate h if theta is 40. Fifth part, theta is equal to 40, beta is equal to 54 and L is equal to 12. You have to calculate h. I'm not going to do that. You can calculate it and I'll give the answer. What is the answer here? For h, you will get 22.33. For the h, you will get 22.33. So what is the, there's another question as question number 5. Question number 4 was they asked for the other measurement that you need to find h. It was L, the distance that you have to pull the inclinometer back, L. To measure that, it's a measurement in the ground, you can use meter ruler. You can use the meter ruler. Okay. Then as the question number 6, you asked to find the value of h when the angles are given 22.33. What is the height of the diagram? 7th part. So h is the, now we left a distance 1.45. The mount, it had a height of 1.45 meters. So our hypothetical triangle, it also had a 1.45 meter height from the ground. From there, the h starts and moves until the top. So h, if it is 22.33, it's from top to this point. From there, you have another downward distance of 1.45 meter related with the length of the support that this inclinometer is attached. So height of the diagram, capital H, 22.33 plus 1.45. Okay, then we will get the answer 23.78. Okay, so what is the 7th one? 8th one. What is the additional measurement? You need to find the height of kotha separately. Then there's another interesting question that I have asked. Now you need to find the height of kotha separately. So this is the complete diagram. Now you need to find the height of kotha. This side, this part, this length. Let's say it's S. How to find this S? What is the additional measurement? You need to find the height of kotha. Use that additional measurement above the value h and the value h to obtain an expression for the separate height of kotha. Okay, let's try to find a method to find the distance h, the distance from here to the top, or the separate distance of kotha. How to do that? Okay. Now here I'm introducing an additional measurement like this. This is my plan. I'm keeping the inclinometer in this place. I have positioned the inclinometer into this place, and I'm observing this point. I'm observing this point. If I do so, I'll get a separate angle. Shall I draw as this is the final question that I'm going to discuss today? Can finish the class within another 5 to 10 minutes time. So let's draw a image separately. So this is it. You have diagram like this, and this is the kotha. Okay. At a distance x from the center, initially the inclinometer was positioned, and you are observing the highest point. Which created the angle theta here. So here the angle is again, as these are parallel lines, angle here is theta. This was h naught and this was x. Tan theta is equal to theta, tan theta is equal to x. Opposite leg divided by the adjacent leg, it's h. This part is h naught, this is h. You have this equation. Now the second thing I suggest, I will draw in the blue color. Keep the inclinometer like this. Aim it for this position. Then you can measure the angle gamma. Then you can measure the angle gamma. If this is gamma, this is also gamma in the same manner. Now I am pointing to aiming to this point. So the triangle is something like this. And I'm doing the same thing. Here, now the weight acts vertically. So here the string with the mass and angle here is gamma. So again, the angle here is also gamma. Okay, I'll write tan gamma, 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 tan gamma, x, tan gamma, opposite leg, it's x. And I have considered the separate height of the kotha as s. The total height from this point up to the top, it's h. Separate height of kotha is s. So what is this height? This height h, this part s, h minus s. Tan gamma, gamma here, tan gamma, opposite leg x, adjacent leg h minus s. H minus s. Okay. So from this, initially the angle here is theta. So the angle here is also theta, tan theta, x over h. So x will be equal to h tan theta. Secondly, I aim the point where the kotha starts. So angle here is gamma. So the angle here is gamma. Tan gamma, it's x again, but this time you have to divide by the blue color distance that I have marked. What is it? From here to top it's h, but the distance of the kotha, length of the kotha is s, so this is h minus s. Tan gamma x over h minus s. From here I can subject x, h minus s into tan gamma. So same x value. So from first equation, x is equal to h tan theta. From the second equation, x is equal to h minus s tan gamma. You know h, 22.33. You know theta, I think it's 40 or something like that. theta is equal to 40 and h 22.33, and to find s, have to find s. To do that, the only remaining thing that you have to find is the gamma. So what you have to do? Again, place the inclinometer at its initial point and aim to the starting point of quarter and read the angle. It is tan gamma. In substituting this equation, it's asking the final question, and you will get the answer for S. Again, take the inclinometer to its initial position. This time, aim it to the initial point of quarter and read the angle. Use that angle to substitute here and substitute other appropriate values h and theta. Then you will get the answer for S. Okay, so this is the situation. Now, for the vernier caliper, I will provide you an answer sheet, a PDF answer sheet. And this is the most important question that you need the discussion. And again, the essay question. We have done them. Okay. I'm going to stop the class for today, and tomorrow you can write the paper at the institute, and Saturday you can write the paper from 7:30 to 5:30 p.m. and then I will give you the marks on Sunday. Try to finish writing it on Friday, as I had to give you marks on Sunday. Even though you write it on Saturday, definitely I will give marks. It's okay. Okay. See you then.